So today we are going to discuss about uh, okay. Today we are going to discuss about views, types of views, secured views, materialized views, and materialized views is somewhat important. So what is a materialized view first of all? How the data will be refreshed in materialized views, and what is the cost implications of materialized views, and when we have to go for materialized views, and what are the advantages of materialized views, and there are some limitations of materialized views. So we are going to discuss about all of these topics today. So let's go to views. So what is view? I think you have good idea because you have database experience, right? So what is a view? In general databases or in traditional databases, what is a view? The same here also. A view is a database object that contains SQL query built over one or multiple tables. So a view contains SQL query. It's a database object first of all, and inside it contains SQL query. That query was built on one or multiple tables by joining the multiple tables. So you can say it's a virtual table. View is a virtual table. So it will not present physically the table, but whenever you run that query or whenever you try to query that view, it will fetch the data from underlying tables, right? So you can consider it as a virtual table, but that can be used almost anywhere that a table can be used. Suppose if I want to select some data from a table, and if I want to apply some operations like filters, joins, subqueries, okay, I can apply all these things on views. Okay, so a view can be considered as a virtual table which doesn't exist in the database, but whenever we try to query that view, it will fetch the data from underlying tables, and we can use these views anywhere in our queries. Whenever you query a view, the underlying SQL query associated with the view gets executed dynamically, and it will fetch the data from underlying table. So whatever I said earlier. So whenever we run or whenever we try to query the view, it will be executed in the background, okay, and it will fetch the data dynamically. That means at runtime it will fetch the data. There will be no stored data in that view, but dynamically runtime it will fetch the data from the underlying tables, uh, whatever the tables we have mentioned in that SQL query. So view serves a variety of purpose like combining data, segregating data, and protecting data. So these three are important. Suppose I have multiple tables, okay, and I don't want to run a query, okay, by joining the I want to fetch the data from all of those tables, but I don't want to run query every time to combine that data. Okay, what I can do, so I can write a query by joining those tables. Suppose I have some tables, employee data, department data, location data, but I want to write a query over all these tables. So in that case, I don't want to run the write that query every time, right? So what can I do? I can create a view, and inside that view I can just put all those giants, and I can prepare one SQL query. I can put that under a view. So next time you don't need to write that giants again. So tens or hundreds lines of code you don't need to write again. So you can simply query that view. It will execute that underlying SQL statement, and it will fetch the data. So we use this for combining the data and segregating the data. So we can apply aggregation. Suppose if I want to calculate some summaries, I have some 4 or 5 tables, but at the end of the day I want to join all those tables and calculate some summary data. Right? So those summaries data I want to store. I don't want to store in a table, but whenever I want to whenever there is a need to calculate that summary, I should be able to run that query. So what I can do, I can create a view over those tables, and next time whenever I feel I need that summary data, I can simply query that view. And protecting data, this is very much important. So in real time, this is protecting data is very important. Suppose I have a global table, okay, very big table with millions of rows and billions of rows, but I don't want all the users. Okay, I have users globally, but I don't want to share the table with everyone. Suppose if I have regions like American region, Asian region, African region, okay, Europe region, I don't want to share all the data with every user, but region wise I want to share the data. How can we share? Okay. So we can create view some with some filter, and we can share that filter data only. So how can you do this? By creating a view with that filter and share that view. Instead of sharing the table, we share that view with the user. So whenever they run that view, okay, so they will get only the required data. They don't want to, they will not get other data. That means we are protecting data. So we are able to control the data. We are able to provide the data security. We are not sharing the uh, not required data, right? We are not sharing all the data. We are sharing only the required data for those users. That means we are protecting the other data. Like the whatever I said was just one example. Like this, based on the requirements of the users, okay, so we are going to share the data. We'll see this in practically today. Okay, so that's how we protect the data. So what are the use cases of use? So to combine the data, to calculate summaries of data, and to protect the data. Okay. And a view can be created with below syntax. So it's general syntax available in any database. Okay. Create or replace view name as the SQL statement. Okay. Create or replace view name as the SQL statement we have to give. Okay, so it should be select statement. SQL statement can be anything like insert, delete, update, but it should be select statement. Okay, so this is about views, and there are some types of views. We cannot say these are types, but we notice three kinds of views in Snowflake. Okay, so they are non-materialized views. That means the normal views, whatever we just discussed. And the second one is secure views. So this is the newly added thing in Snowflake, which is not available in other databases. And the third one is materialized views. So I think you must have idea about materialized views. It is same as the other databases. So in general, in Snowflake, we notice three kinds of views: non-materialized views, secure views, and materialized views. So let's discuss about each of them. So we already discussed about normal views. Okay, what is normal view and what is the use of it and how to create that view and how view works. Okay, so now let's go to secure views. So what is meant by secure view and what are the uses of this secure view and how to create this secure view? So a secure view does not allow users to see the definition of the view. So whenever we build a secure view, and if we share that view with the users, okay, so they cannot see the definition of the view. That means they cannot see the underlying SQL statement. So we are giving the SQL statement here, right? Create or replace view, and we are providing some SQL statement, right? Whenever we create the view as a secure view, that means with the secure keyword. So the users to whom we are going to share the view, they cannot see the definition of the view. Okay, users cannot see underlying SQL query. Okay, the definition of a secure view is only exposed to the authorized users. That means users who have been granted the role or owns the view. So mostly we don't grant the access to other users with for the secure view. So only owner can see the definition of the view, and whatever the users we are going to share that view, they cannot see the definition of that view. Okay, so why secure views? So why we have already views? We are able to provide the data security by using views. And what is the use of secure views again? So there are mainly two advantages of secure views. Okay, so first thing is we can protect the data by not exposing to other users. Okay, so you may be little confused. So already you are providing the data security. So what is that mean by you can protect the data by not exposing to other users? Okay, so I have a use case. Okay, suppose whatever we discussed last time, providing data security region wise. So I have a query like this: select star from the customer table where region is equal to Asia. Okay, so whenever I create a view with this statement and I share it with user, what will happen? He can see the data and he can see that SQL query also. So by seeing that SQL query, what he will get some idea like so okay, this is the SQL statement. That means this customer tables not only contains the Asia data, but it contains the other regions of data, right? So he will get some idea what are the data present in the table. But that is kind of not a secure, right? So we don't want them to even guess what is the data available in the table. So if I am sharing some data with him, so he should be able to access only that, but he should not make any guesses and he should not know about the other regions, right? So whenever you create a secure view, he cannot view the definition, right? So that means only whatever that the data he is getting, he may think like, okay, this is the data available in that view. Okay, so we are protecting the other data, whichever we are not sharing, some part of data we are not sharing, the sharing, right? So we are not exposing that other data to the users. Okay, and suppose if I don't want to see the other users underlying tables present in the database. Suppose I have some 20 tables and I have written my query SQL statement on 10 tables. Okay, and we are sharing that view with the other users. So whenever the other, if we are not creating a secure view, the other user can see what are all the tables present in our database. Okay, but I don't want to see what are all the objects present in my database. So he needs some data and I'm providing that data. So why he needs those tables, whatever present in our database? I don't want to share those. I want to protect my tables. Okay, I don't even want any other users to see what are all the tables in my database. So if we create a secure view, what will happen? He cannot see the definition, right? So he will not be aware of what are the tables present in our database. Okay, so these are the two main use cases of secure views, and mostly we create secure views in Snowflake, not the normal views. But the functionality is same whenever you create secure view and whenever you try to query the data from secure view. So runtime it will go and fetch the data from underlying tables. Okay, the functionality is same, but there are two main advantages of these secure views. And how to create this secure view? We just have to place secure keyword. Okay, create or replace secure view, view name, and the select statement. Okay, and so how to determine a view is secure or not? Okay, so there is a field called is secure. Okay, in the table information schema. So whenever we create some database, by default information schema will come, right? And this information schema stores all the data about the tables and views we are going to create. And there is one more schema, account usage, but account usage can be accessed only by account admin. Okay, so if we want to know this view is a secure or not, so I just have to simply execute this select statement. Okay, select a star from this uh, information schema dot views. Information schema dot views, this is the table that is storing all the table and view information. Okay, where table name equals to, we have to provide view name. So it not only contains views but also it contains the tables also. That's why we have to provide where table name equals to, we have to provide the view name. Then it will show you the table name, schema name, okay, database name, where it is stored. And there is a field in this table is is secure. So if it is a secure view, it will show you, okay, it is secure. Otherwise it will just say no. We'll see this in our lab session today. Okay, and the same, it is available in the account usage views also. Okay, but we cannot see this because in the real time we are not going to be the account admins. Only account level they can see this, but as a user, if we want to see, we can query this table. Okay, so let's go to the other one, materialized views. Okay, so what is a materialized view? I think you worked with the database, you must have idea. So I'll quickly go through. So a materialized view stores pre-computed result set. That means whenever we create a view that is kind of materialized view, so it will store the result set. Okay, so instead of every time going to underlying tables and fetch the data, so whenever we create a materialized view, and it will store the result set, whatever we are doing in that query, that result set it will calculate and it will keep it. Okay, and whenever we query a materialized view, it definitely gives the better performance than querying the underlying tables. Okay, that is right, because the result set is already stored, so it will not go and fetch the, it will not go and fire that query again on the database tables. So it will just fetch that pre-computed result set. and we can create, so the limitation is we can create this on a single table. I think in the traditional databases also it's same. So we cannot create materialized views on multiple tables. Okay, so it can be created only on a single table. Okay, and this is mainly designed for query improvements, query performance when we are using same data set repeatedly. Suppose if there is a user, he will be running the same queries again and again every time, every day for his business analysis. That time what he can do, so instead of writing that query again and again, he can simply create a materialized view. Okay, and he can execute that query because he will get the data set will be stored, the result set will be stored, and he will get the data immediately. Okay. And this is available only in enterprise editions and higher editions. So this is not available in the standard edition. It is available in enterprise, business critical, and virtual private. Okay, and same as secure view. So if we want to create materialized view, we have to just mention this materialized keyword, create or replace materialized view name as the select statement. So you may get some questions, but let me go through the other slides also. Most of your doubts will be cleared. Okay. So how to refresh materialized views? Okay, so you may get a doubt. So we have created one materialized view, and at the time of creating the materialized view, whatever the data present in the table, that will come and stored in that result set. Okay, but what happens if we are modifying the underlying tables? How the data will be refreshed in the materialized view or not? Okay, so we don't need to refresh this data manually. A Snowflake performs some automatic background maintenance of materialized views. That means, so we don't need to refresh. We don't need to execute any query to refresh the data in materialized views. But there is a process, background process running every time in the Snowflake. So what it will do? It will sync up the materialized views. So even though you are updating data every day or every week, okay, so this data will be refreshed automatically in the materialized views, but it may take some time. Okay. It generally takes 1 or 2 minutes. Okay, so when a base table is changing, that means the underlying table is changing. Snowflake runs a background process to keep the materialized view up to date, but it takes some a minute or 2 minutes to refresh the data. Suppose I have a table, I have some 1,000 rows in the table, and I had created a materialized view over the table, and every day I'm inserting some 100 rows into the table. So we don't need to refresh that materialized view every time manually. So whenever we are inserting some records into the table within a minute or 2 minutes, okay, it will refresh the data in the materialized view as well. So whatever the data present in the base table or underlying table, the same result set will be stored in that materialized view as well. So we don't need to worry about refreshing the materialized views. So what is the cost of materialized views? This is important because there is an impact of cost on the materialized views. It will impact your cost, both storage and compute resources. So let's see how it will impact. Storage cost. So each materialized view stores the result set, right? So it's not only we are not only storing the table level data, but here we are storing the query result set, right? Which adds the monthly storage usage for your account. So if you have 100 materialized views, that means 100 result sets it is storing extra. So for storing those data, so this data sets will be stored in the storage layer only. Okay, that's why whenever you create a materialized view, there will be some storage cost associated with that to store that result set, pre-computed result set. And when it comes to the compute cost, so I told already, so whenever we are doing some modifications to the base tables and underlying tables, Snowflake background process will run. So how this process will run, it has to consume some resources to run the refresh, right? So it uses Snowflake provided credits, Snowflake provided resources or virtual warehouses to keep the data up to date. Okay, so definitely to run that background process, some virtual warehouses will be required. So there will be some compute cost associated with the materialized views as well. So in most of the organizations, if they feel there are some okay, So there are some rules when to create materialized views. So if we are satisfying those rules, then only we are going to create the materialized views. Unless until we don't create, because there will be so much cost associated with materialized views. These are very costly in real time. Okay, because if your table containing million rows, okay, and if you are creating a materialized view over that, again it will store that million results data set, right? So that means for every table, if you are maintaining a materialized view, that means your storage cost is doubling, and also compute cost is also too much. So unless until it is required, okay, we don't create materialized views in Snowflake. So when to create materialized views and when to use normal views, okay, that is important. Let's see. So when to create the materialized views. So create a materialized view when all of the following are true. This is the suggestion from Snowflake, that, but this is not a mandatory. So whatever it is available in the Snowflake documentation, they are recommending some rules when you can create the normal views and when you can create the materialized views. So they are suggesting you can create a materialized view when all of the following are true. So when the query results from the view do not change often. Suppose I have a query, I have a table, and I have some data in that table, and it is not going to change often. Suppose I have some weekly load or monthly load. Okay, that means that the data will be changed only once in a week or once in a month. So in that case, we can create materialized view on the table. But every day, so suppose every day, not only every day, every hour you are doing some data loads into the table. What will happen? Every hour, if you load the data, every hour the background will process will run, okay, to to keep the data up to date. So what will happen? The compute cost will be more. So uh, they are suggesting run your okay, so what they are suggesting, the query results from the view do not change often. So whenever you are not modifying your table very often, so then only you create the materialized view. And the result sets of the view are used often. So not only the result set is being modified, but there should be a use case of that one also. So any user and they are using that result set frequently, unless it is not required, right? So suppose if I have created a materialized view and no one is accessing that materialized view, okay, till a month or 2 months, so what is the use of that? So if we have users, they are frequently querying that materialized view, then only we have to create materialized views on that table. Otherwise, don't create. And the query consumes a lot of resources, means query takes longer time for processing, like aggregating the data. So whenever you have some table and you are running single table, okay, and you are running queries on the table every day, and they are costly. Suppose you are applying aggregate functions or window functions. So mostly aggregate window functions will not be supported. Suppose you are calculating summaries of data. Suppose you have some millions and billions of rows and you are calculating some summaries, and user need that summary data for every hour. So in that case, he can create a materialized view over the table, and he can put that group by query in that on the table. So whenever he fetches the data, okay, so it will not go to the underlying table, but the data will come from the result set. So pre-computed result set. That means a lot of resources will not be consumed, and the query even will not take long time. So it will fetch the data fastly, right? So these are the recommendations given by Snowflake. So when you are satisfying all these scenarios, when the table is not being modified often, and when the results are being accessed very often, and your general query is taking long time, then only you create materialized views on those tables. Okay. And what they are saying, create a regular view when any of the following are true. Suppose the results of the view change often, whatever I said. If we are modifying the underlying table for every minute or for every hour, then don't create a materialized view over that table, because the materialized view maintenance cost will be too much. And when the results are not used often, so whatever I said in the earlier, okay. So if we don't have any users, they are using the materialized views often, okay, then no need to create materialized views. You can go with regular views, okay. And when the query is simple, Okay, so if you have a simple query, just like select count of one or select count of star or select star from that table, so it's a simple query. It will not take much time to execute. Okay, in that case, no need to create the materialized view unless until you have so many filters or so many you are summarizing the data with the group by. Okay, then only you go for that. If you are putting some simple select star from, then don't create materialized view. You can create regular view. Okay, and your query contains multiple tables, so definitely, because materialized views cannot support multiple table joins. Okay, so it can be created only on single table, but your requirement is to get the data from multiple tables by joining them, then go for regular view. Okay, so these are some recommendations by Snowflake for creating views and materialized views. Okay, so what are the advantages of materialized views? So definitely, the biggest advantage is it improves the performance. It will not go and execute that underlying query every time in the database. Instead, it will fetch the data from that result set. Okay, pre-computed result set, and no need of additional maintenance. So Snowflake is maintaining auto refresh. So there'll be no manual work for for refreshing the materialized views. Okay, and the data access through materialized views is always current. So you don't need to bother about like your data is up to date in the materialized view or not. As Snowflake is running the automatic background process, it will keep your data up to date. It may be a minute delay, but it will keep the data, and the data will be available for all the users for their analysis. Okay. Okay, these are the advantages of materialized views, but the first thing is very important. Next two are not, they are just concepts, but the first thing, query improvements. Query performance is the biggest advantage of materialized view, and even there are some limitations of materialized views. Okay, so we can query only a single table by using materialized views, right? So you cannot build the query on multiple tables, and so it doesn't support joins including the self joins. So even though you are operating with one table in the materialized view, it will not support self join also. That means you cannot join the table with that table also. Okay, and anyway it won't support any joins, and it doesn't support all aggregate and windowing functions. So it supports some basic like count of star. Okay, max, minimum. Okay, those things only supported, but there are other aggregate functions. They are and windowing functions like lead, lag, okay, dense rank, row number. So all this won't be supported by materialized views. And when the base table is altered or dropped, the materialized view is suspended. Suppose I have a table with the 10 fields, and I have created one materialized view over the table. And in future, if I am going to change the table definition, that means if I am altering the table by creating another field or dropping the existing field, so immediately the materialized view will be suspended. So it will not exist. Okay, so you cannot view that. You cannot uh, see that materialized view anymore. So if you are changing the table means you have to recreate your materialized view again. Okay, and materialized views cannot query another materialized view. Suppose views. So in views you can query another view, right? But in materialized view you cannot do that, because if you want to use materialized view inside the materialized view, that means you have to provide some joins. Okay, and you can but the joins are not supported by materialized view, and you cannot query another normal view also inside the materialized view. Okay, and you cannot choose any user defined functions in the materialized views. So these are the limitations. So it mainly when a user is dealing with only one table, and he is running that query frequently. It's a difficult query, like he is calculating some summary data, and he is running that query very often, like every hour, every day. In that case only we are going to create materialized views. Unless until we won't create materialized views in Snowflake. Okay, so this is about materialized views, and not only materialized views. So this is about all the views present in want to use sysadmin from now onwards. In the ongoing all ongoing sessions, I'll be using sysadmin only. Okay, so So first let's try to create some views. Okay, then we'll create a secure views and materialized views. So how to create views and how to view the data, we'll see. It's very simple like in any other databases. Okay, so first of all I'm using this public db. Okay, so whatever the database we had created yesterday, so we had created a public db yesterday, right? So my own db is not available here if you see, because that is available in the account admin level and we haven't provided access to sysadmin for the table for that database. That's why we have created one database called public db yesterday, and we have these two views available in that db. So I'm going to use that db for our purpose today. Okay, so I'm setting it. Okay, and to store my views, okay, I'm creating one schema called MYVIEWS. So whatever the view, normal or secure or materialized view, I'm going to store all my views under this table. Create schema MYVIEWS. Okay, so if you just refresh, it should come here. Okay, so MYVIEWS, we have MYVIEWS schema here. Okay, and so suppose just take a requirement, some requirement. Okay, and before that I want to explain something here in the Snowflake sample data. As we have so much data here for our practice, so I'm not going to load any data, or I'm not going to create any extra tables for this purpose. So I'm simply using the data available here, because here we can see billions of data is available, so we cannot create those much sample data, right? So it's best practice to use the data available here. Okay, so we can operate any of this because structure wise they are different, but they will contain a different number of rows as I explained earlier. Okay, just take anything here. Okay, so if you see here, there are customer table, line item table, nation table, orders table, part table. Okay, there are some set of tables with some sample data. So let's see some table. Let's open some table. Okay, I'm just clicking and you can see the table structures here. So instead, you can just go and preview the data. So if you see the data in the customer table, so we have the data like customer key, okay, customer name, customer address, and customer nation key. That means the country of that customer, but they are not giving the country code, but they are giving the key, country key. Okay, they are not giving the description of that country. Okay, and the phone number of that customer and account balance of that customer, and some other fields, some comments and marketing segments of that customer. Okay, now so I want to fetch the data. My requirement is to create the views, there should be some requirements, right? We don't simply create views. So if any user is asking for some data, that means he has some requirement with that data, then only we are going to create a view for that purpose and we will share that view with the user. So here my requirement is, so some user is asking me the contact details of Brazil customers. Okay, so he doesn't want all the data, but he wants, and he doesn't want all the data, and at the same time he doesn't want all countries data. Okay, so there are so many fields in this table, but he is particular about the contact details, and he is particular about Brazil customers data. So in that case, I will not simply provide access to this customer table to that user, because unless why he needs all the data, why we have to share this table. So when he is requesting only some part of data, some part of fields, we can create a view and share that view with that user, right? So this is the advantage. So we don't need to share all the data here. So what is his requirement? He needs only Brazil data, Brazil customers data. That also only contact details. Contact details means the address and phone number. So if they want to reach by phone, they can reach. If they want to reach physically, they can contact on this address, right? So let's see how to create this. And he is specifically saying I need Brazil customers. So but if you see here, I don't see anywhere the Brazil, the country information is not available here. But if you see here, there is a country key, nation key is available here. That means there will be another table, nation table, with country codes or country description, right? So let's see if we have any table here. So we have another table called nation here, and let's come to this. we have nation key and nation name also here. Just to try to preview this data, and here you can see. Okay, so all the country codes, there are 24 countries, and there are 24 country codes and the country descriptions here you can see. Okay, so what are the country keys we have? Algeria, Argentina, Brazil, Ethiopia, France, Germany. We have so many countries, but this user wants the only Brazil data. That means I have to get this field from the nation table. So how can I get this field? By joining the customer table and nation tables by using the join key, nation key. So our joining key will be like nation key will be our join field. So this is how I'm writing this query. Select the required fields. So whatever the user required, the customer key, customer name, customer address, and phone. So he wants only contact details. So that's why I'm ignoring the other fields like bank balance. Okay, and there was some more fields, marketing segment. Okay, and comments. So I'm ignoring those because he wants only the contact details. That's why I'm selecting only these fields from. So Snowflake data, Snowflake sample data, this is the database, and this is the schema I'm going to use. Okay, so in this table we'll have only 150,000 rows, but if we go here, almost 150 millions of rows are available. That's why I'm trying to use this one. Okay, use this schema, and I'm selecting from customer table. I'm just putting one alias name as CST, and I'm joining this with the nation table. Join, inner join, Snowflake sample data, the same schema, and this is the nation table I'm joining, and I'm giving alias name as nation. I think you must be aware of joins, right? Inner join, left outer join, everything. So this is
Yes.
simple, like any other database. So we are joining by using a key called a nation key. So we have this key in both the tables, customer and nation table. I'm joining it, and then I'm putting my filter where the nation name is Brazil. Okay, so that means I'm putting my filter over the nation table, and I'm joining my nation table with the customer table by using the nation key. Now I'm creating a view with this. Okay, it's as simple as we prepare the SQL statement. So we have to prepare one SQL statement, and we have to create a view with this. So my view definition is like create or replace view, and the name. So I'm storing this name, this view with the name view underscore customer, and I'm storing it under my views. Okay, so create or replace view name, and I'm just putting the select query here. So let's try to do this. So view has been created. Now let's try to select the query. So query this view. These statements are very useful. These comments are very useful. Okay. So before executing these statements, while you are practicing, just read these statements. Okay. So now query the view and see the query profile, how it is fetching the data from underlying tables. So definitely, even though we are querying the view, it should go and connect with the underlying tables, right? So we can see that in the query profile, how it is coming. So let's run this. Okay. So it is fetching the data, and it took almost 2.45 seconds. Okay. So it is fetching the customer key, customer name, address, and phone. So it is not fetching all the details. Whatever we specified in the view definition, it is fetching only those fields. Okay. And how can you make sure if there is a key we can, okay, we'll see that later. Okay, so these are the only this customer whoever requested for Brazil data. Okay, Brazil customer data, he can see only this data. He's not aware of other fields, like he has some Egypt customer, he has some France customer, he will not be aware, right? So now let's see the query profile for this query. Okay, so if you see here, okay, so it is clearly showing whatever the steps it is executing, the query engine is executing. Okay, it is showing all our steps. First of all, it is fetching the data from two tables. Okay, one is customer table and the other is nation table. And then it is on the nation table, it is applying some filter. Okay, and it is not applying any filter here, but after filtering this data, it is applying a join on both the tables, both the data sets. Then it is showing us the result after performing the join. So it shows all the query steps what it is doing. And if you observe here, okay, so the right side, whatever we had discussed in the other sessions. So if you see here, it is percentage of scan from cache. As we are executing this query for the first time, it is fetching the data from the remote disk. Okay, if you try to fetch the query again, if you try to use this query again, that means you run this view again, so it will not fetch the data from remote disk unless it will go to cache and it will fetch the data from result set. Okay, results cache. Let's see that. Okay, so I'm running this again. So it is using the query results reuse. That means it is getting the results from uh, results cache. So even though you are running different queries and different views, but if the result set is available in the results cache, it will fetch the data from there itself. Okay, so we can combine the concepts here. That's what I want to show. Okay, even though you are querying the views, the underlying tables are same, and the query results will be used. Results cache will be used. Suppose if you want to see that, you can just alter your session. You can turn off your results cache and you can try to run this again. Okay, so it's not required because I have shown this multiple times. But for your practice, you can do this. You can turn off your results cache and you can suspend your session. You can suspend your warehouse and try to run this query again. It will fetch the data from underlying tables, not from the results cache or not from the local disk cache. Okay, so that you can do in your practice. And let's see how to share this view. So we have created the view, but we have to share this view with that customer, right? Whoever is requesting the Brazil data. So whatever the things we have to do, so we have to first grant the usage on this database, public DB. Suppose we don't have any specific user, I'm just sharing with the public role. That means anyone can see this data. Okay, so we don't have any specific this thing right here. That's why I'm sharing this data with public. That means anyone can see the data from this view after that. Okay, so let's try. And I'm granting the usage on the schema for this view. Okay, and I'm granting the select privileges to to this view to the role public. Okay, so if you have specific customers, specific users or specific roles, so we can simply put that roles or customers here. Suppose if I have a user ABC, so what I can say, grant this access to the instead of role you can say user, and username you can specify, unless you have a specific role. Okay, Brazil role underscore Brazil. So that means there are multiple users in the Brazil who is accessing this data. So you can you can simply use that role name here, but we don't have any roles. That's why I'm just using the public role. Okay, okay, so this is how you can share this views. Okay, now if you go, you can go to this public role and you can try to fetch this data from this view. It will come. We'll see that in the secure views part. Okay, so this is about views. I think it is simple. So let's jump to secure views. So here uh, I have another requirement. Okay, need all details of American customers. Okay, it's not country wise now, but it is like continent wise or the region wise. Okay, so we have different regions, right? American region, African region, Asian region, Europe region. Okay, so now a customer is requesting all the America customers data, all the details, not only the contact details, all details of American customers. Okay, now we want to create a view for this customer and we have to share it with that customer. So how to build this query? It's same. Okay, select instead of only contact details, I'm fetching all the details. Select cst.star from Snowflake sample data customer table, and I'm joining it with the nation table. And if you observe in the nation table, we have region key also. Okay, so that's how I'm joining. Let's show me that region table, then you will get some idea. So if you see the regions, there are only 4 records. Okay, 5 records. Okay, Africa, America, Asia, Europe, and Middle East. There are only 5 regions if you see, because the region key is starting with 0, 0, 1, 2, 3, 4. That's why we have 5 regions. Now I want to only share the Americans data. Okay, I don't want to share all the data. Even the customer is requesting all the details of American customers. Okay, now I'm writing a query like this. So after joining this nation table, I'm putting one more inner join on that region, and I'm joining this region table by using the region key, and then I'm specifying the filter as region name equals to America. Okay, so this is how I'm preparing my SQL statement, and I can just simply create a secure view. So how can you view the results from the secure view? Just select star from secure view underscore customer. So I have given the name as secure view underscore customer for this, just for our understanding. Okay, now what we have to do? So we have created the view and we are able to see the results, but you may get doubt. So how can you make sure? Okay, this is only Americans data. Okay, so you can you can write a query on on this view. You can join this view with this region table, and you can fetch that region name. Then you will get only the distinct region name as America. Okay, if you want to do that, you can do that later. Okay, so I have created the view and I'm able to fetch the data from that view. And so if I want to share this again, I have to run this grant usage and grant select. Okay, let's try to run this firstly. So I have shared the data to public. Okay, and how can you identify this view is a secure view or not? Okay, so I told you, right? So we have a table called information schema, and inside that we have a table called view. Okay, so if we just run this query, select these details from information schema, it will show all the views present in that, views and tables present in the in our database. So if you see here, okay, it's showing the views in the top itself. Okay, so in public database we have created a MyView schema. Inside that I have 2 views. One is view underscore customer and one is secure view underscore customer. And if you see this field is secure, it is showing yes, and for this it is showing no. That means this is only the secure view we have in our schema. Okay, and you can run this query also, show views. Okay, whenever I am doing this, you have to observe carefully here. When I am running show views, even though this is a secured view, I am able to see the definition here. Okay, so if I just click here, it is showing me the definition because I am the owner of this view. That's why I'm able to see this definition. So what is the main purpose of secure view? I want to hide the table DDL or view DDL from the other users. Let's try. So I will switch my role to public and let's execute the statement again. Okay, so how to switch the role? Here we have. Okay, I am switching to public role. Okay, and I am executing this show views. Okay, so if you observe, okay, you cannot see the table definition for secure view. So this is your secure view and you don't see any text here. So whenever only owner can see this definition, others cannot see this definition. Okay, unless until you grant the ownership to them, they cannot see this definition. So this is the main purpose of secure views. They cannot know whatever we are doing in the select query. They can just only fetch the data from that view. Okay, so this is about secure views. This is the only thing you have to observe. Like whenever the other users other than the owner, any others using this secure view, they cannot see the definition of that view, but they can fetch only the data from that view. Okay, this is the main difference between view and secure view. Okay, now I'm switching back to my sysadmin role because I want to create materialized views now. Okay. So whenever you something is not querying, something is not working, or if you are getting authorization errors, just look over your these things. Okay. So make sure you are selecting the proper context. So we call this as context. So you have to select proper context. That means the user, the database schema, you have to choose it properly here. Okay. And coming to the materialized views. So here my requirement is I want to check frequently. Okay. The high priority order details. So if you see here in the schema, we have another table called orders. Okay. So I have a requirement. Okay. I have a requirement where I want to see my order details. Those are with high priority. So if you see here, just try previewing some data from this one. So if you see here, there is order priority here. Okay. Order priority here in this column. And if you see the distinct priorities, okay, 4 is order priority not specified, 1 is urgent, 5 is low, 4 is not specified, okay, and 3 is medium, and 2 is high. Okay, 2 is high. So I want to fetch only high priority order details frequently. That means for every 5 minutes I want to run a query that contains high priority orders. Okay, so this is my requirement. Okay, so before that I want to show you one more thing. Let's take this query. Okay, so I want to show you materialized view won't work on multiple tables. So okay, so I'm trying to create a materialized view with multiple tables, because if you see here, I'm joining multiple tables here, right? So let's try to build a view, create materialized view with some name, and this is my query. So whenever I execute that, it is showing me one error. Okay, more than one table referenced in the view definition. So it is a materialized view, and you are using more tables, more than one table. That's why it is not running. Okay. I'll put some comment later. Okay. So, but my current requirement is I want to fetch only high priority order details from the database. Okay, that is my requirement. So how can I do that? Okay. So, and I want to create a materialized view over that. So suppose select star from this Snowflake sample data, and from this orders table, where substring of this the first character indicating our high priority, right? So I'm just doing some substring. Okay, and I'm putting some order priority. I'm just getting the first character by using the substring. Okay, if that is 2, that means 2 is high. We have seen in the sample data, right? 2 is high. So if I want to fetch only that data, I can just write a filter on this. Okay, where the substring of this order priority equals to 2. That means it will fetch only the high priority orders data. Okay, let's see. So we have so much data here because we are operating with almost how many records? 150 million records, right? Let's go and see how many order records are there. So it displayed the results in 16 seconds. And if you see here, 150 million records are there in the order table. Okay, so now let's try to build this view. Okay, create materialized view, view name, materialized view underscore orders. I'm giving just this name, and I'm storing it under my views, and I'm putting this select statement over here. Suppose I have another requirement, and I want to fetch only the details, high priority details of some particular date or some particular month. How to fetch? Suppose I want to fetch the high priority details of only this month. That means 2022 July month I want to fetch. So how can you do that? So we have a ordered date. Order date you can fetch simply by using year of order date equals to 2022, and month of order date equals to 7. you can put a one more query like this, one more condition like this, but the data is not available for 2022, so all the data is available for 1997, 98 like that. That's why I'm not using this condition, because these are not up to date tables, right? They are old tables. Okay, so if we can add any number of filters, or we can add a group by over here. Okay, so let's try to build this view. So they don't care about all the high priority orders, right? They want all the priority orders from this month only. So in that case, they can just simply put this. Okay, conditions. So materialized view has been created, but it takes some time, okay, to calculate the result set and store it somewhere. Okay, so whenever you run this, okay, so the view name was not correct, that way. Select star from this one. Now it is going to this materialized view. So that means it's not yet refreshed the data. So if you run this query, if you just try to fetch this data after 5 minutes or 2-3 minutes, okay, what will happen? It by that time it will fetch the data and store it in the result set. So this it will come in milliseconds only. Okay, you can try that later. Okay, so now you can see, right? It refreshed the data in the result set, and it is giving me within 120 milliseconds. Oh, maybe it is reusing the results, not fetching. Yeah, it is reusing the results, but you can switch off this. If you want to try, you can turn off this query results, and you can suspend the session, and you try to run this query. It will fetch the data within seconds or within milliseconds, but it will not going to, it will not take some 15 or 16 seconds. Okay, you can try that at your home. Okay, and if I want to see the refresh history of my materialized view, how can I check? That means when the underlying tables are getting modified, and when that data at what frequency this view is getting refreshed. Okay, so if we want to check that information, we can check from this information schema materialized view refresh history table. So we have a materialized view refresh history table in this information schema. It stores all the refresh history of all the materialized views we have. And if I want to check what are the materialized views I have in my database, I can just run this query, show materialized views. Okay, so if you see, this is the only materialized view we have created and available in our database. And if I want to check the refresh history, so because we haven't done any changes to our underlying tables, right? So that's why it is not showing any refresh history. It is not refreshing the data. Okay, but if you are doing frequently, if you are frequently changing your underlying tables, then only it will appear here, the data refresh history. Okay. Thanks for watching. Please subscribe to my channel.